Very good question. ABC is a 3-digit number. ABC is a 3-digit number such that ABC are in GP. How many such numbers are possible? ABC. ABC is a 3-digit number. If it is a 3-digit number, how many numbers are possible? If R value 1, 111, 222, and so on up to 999. Are you all with me? 111, 222, and so on up to 1. Next one, R, these when the common ratio is 1. 124, 124, which is 248. 124 double is 248. 139. 139. What is the next number? 469. What is the next number? 469. 469. 36 equivalent to 4 into 9. So what is the any other number that is possible? 421 is also possible. 124, 421, 248, 842, 139, 931, 469, 964. 964. Are you all with me? Right? I hope it is there with me. So R equivalent to 1, R equivalent to 2, R equivalent to 3. Only thing here is R equivalent to 3 by 2. R equivalent to 3 by 2. So total how many cases we got? Here 9 cases, here we got 9 plus 4 13, 13 plus 2 15, 15 plus 2 17. 15 plus 2 17, but it became an enumeration method. You are enumerating it. You are enumerating it. You are enumerating it. Now shortcut. Please write down method 2. Method 2. Please write down this method 2. I will just change the question like this so that you will understand. Method 2. Method 1 clear. R value 1, R value 2. Right, left to right, right to left. Only thing which you will miss maybe is 469. Maybe is 469. This is the case where you might miss. This is the case where R is a fraction. Where R is a fraction. Remaining all the cases, R is a natural number. Reverse means it will get 1 by natural number. Please write down a question. Write down a question. From the set of, please write down a question. This is where you can avoid the counting. From the set of first 20 natural numbers. From the set of 20 natural numbers. First 20. That means starting from 1. From the set of first 20 natural numbers. How many numbers? Please write down, sir. How many numbers? How many numbers ABC can be chosen? ABC can be chosen such that they are in GP. Such that they are in GP. They are in GP. This is the question, right? From the set of first 20 natural numbers, how many natural numbers ABC can be chosen such that they are in GP? Now see here, sir. Nothing you do, sir. How many natural numbers are there? 20. Now ABC are in geometric progression. If ABC are in geometric progression, B square equivalent to A into C. B square is a perfect square. B square is a perfect square. Perfect squares, which all values it will take? Till 20. 1, 4, 9, 16 it will take. Am I right? 1, 4, 9, 16 it will take. Forget if B square is 1, B value is 1, right? If B square is 1, B value is 1, A value will become 0. A, right? I hope it is clear, right? Are you all with me? Right? Let us put a condition. A is less than, B is less than C. A is less than, B is less than C. Now, how many natural numbers are there? 20. 20 divided by the next perfect square. 20 by 4 is 5. What is this 5? Please listen carefully. If B square is equivalent to 4, If b square is equivalent to 4, what will be b value? B value is 2. A is less than b. It is 1, 2, 4. 1, 2, 4. Then it's duplicates. 2, 4, 8. Then it's duplicate. 3, 6, 12. Then it's duplicate. 4, 8, 16. Then it's duplicate. 5, 10, 20. You don't need to count it. When you do 20 by 4, automatically you got 5. 5 are nothing but all the basic and the derived triplets. Basic and the derived triplets with b value 2. What is the next value? B square is 9. 20 by 9, which is nothing but 2. If b square is 9, what is b value? 3. So it is 1, 3, 9, 2, 6, 18. Are you all with me? Next one, b square 16, 20 by 16, which is 1. B square is 16, b value is 4, 1, 4, 16. Directly I got all the cases. Where r is a natural number. Condition is I kept it is a less than b less than c. Otherwise you do the reverse case and you will get the answer. Again I am referring to nothing, no counting is required. A, B, C are in geometric progression. If A, B, C are in geometric progression, b square equivalent to a into c. First root cause of the problem, b square is a perfect square. If b square is a perfect square, what are the perfect squares? Write down 1, 4, 9 and 16. 1, 4, 9 and 16. If b square is 1, b value will be 1. Condition is a less than b less than c. A cannot be any natural number less than 1. This condition is out. B square equivalent to 4. B value is 2. Forget about it. 20 by 4 is 5. What is these 5? These 5 says that 5 are the basic or the derived triplets where b value is 2. 1, 2, 4. 2, 4, 8. 3, 6, 12. 4, 8, 16. 5, 10, 12. Similarly, 20 by 9, 20 by 16. 5 plus 2 plus 1. I got 8 values where r is a rational number. Where r is a rational number. R is a natural number. Then we will do rational number. Where r is a natural number. I hope you understood that idea. Now what we will do is, we will do one more question. Then we will take r is a fraction. No need of counting. Generally in my class, counting based approaches I avoid it unless and until it is fundamental principle of counting.